Representing data, example 1. In this example, we're asked to look at the number of absences for each pupil in a class given one term and draw a stem and leaf diagram to represent the data. Now, if you have a look, there's lots of numbers that are single digits, lots of numbers that have a tens, and quite a few numbers that have a 20s. Because there are so many numbers, what you can actually do in a situation like this is split into 2 rows. Now, you'll remember doing stem and leaf from school, and you might be inclined just to put 0, 1 and 2 in the column. But what you can do when you know there's going to be a lot of entries on one row is split the row in half. So the first one will be all the values 0 to 4, and the second row can be 5 to 9. Now this isn't compulsory, but it does help you see the shape of the data a little bit better, which is what a stem and leaf diagram is for. So if we go through the data, from the top we've got a 7, that will go on this row, a 6, that will go on this row, don't need any commas, 12, that will go there, 14 in this row, 3, that will go there, and so on. Now, if you go all the way through all the data, you'll have jumbled numbers on each of the rows. What you can do then is reorder them so they're in the correct order on each row, and we need to do that in order to find the median. So if I just write out what I got, you have a go at this yourself and you check that you've got the same thing. So I got 4 2s, 3 3s and 4 4s. And there are 14 items on that row, so I'm just going to write 14 there at the end. So the next row, remember, is the values that start at 5 onwards. I'm going to try and line them up with the values above, because remember it's the shape that we're after. 7, 7, 8, 9, 9. And I'm trying to keep the values lined up under each other. There are 8 values on that row. The next one, I got 0, 1, 2, 2, 3, 4. 6 values I got on that row. On the next row, 5 and 8, 2 values. And then there was a 22 and a 25, 1 on each row. So tick, you got that. That is an ordered stem and leaf diagram. We put them in order and we need a key. So the key, choose any number, 21. 21 absences. That is what 2/1 would denote. Okay, we're now asked to find the median and quartiles of this data. So we don't need to look at this one, the one that isn't in order. We'll look at the one that is in order. So the median is Q2, that's n over 2. Now, we need to count up the number of items of data that we've got. And if you count it up here, I think you'll find there's 32. So 32 over 2. We're after the 16th. Now remember that rule from the previous booklet. If it's an integer, you do that value and the one above, add them together and half it. In other words, find the mean. Now the reason I put these totals is to help me count up where the 16th value is. There's 14 on the first row, so I don't need to count them. There's 14 on there, 15, 16, 17. So they're both 6. So if you add those together and half it, the answer will be 6. Q1 is n over 4. 32 over 4 is the 8th. Again, because it's an integer, we do the 8th, add the 9th, and half it. So going along this row, if you count the 8th and the 9th, they both happen to be 3. So the lower quartile is 3. And then if we do the same thing with the upper quartile, 3n over 4, that's 3 times 32 over 4, and that works out to be 24. So again, because it's an integer, remembering our rule, we'll do the 24th, add the 25th, and half it. So we have 14 on the first row, plus another 8, that would give us 22. So there's 22 on the first 2 rows, 23, 24, 25. So it's 11 and 12, these two values. So it's 11 add 12, half that, that gives us 11.5. Okay? The last part says comment on the distribution of the number of absences. Now there's two ways to do this. You can look at the diagram and see that it starts off high and comes down low. So it has this kind of shape. So like we said in the previous booklet, we've got a positive skew, but we can also use a rule that we're going to look at later in the booklet. So if you've already looked at this rule, it will be helpful. If you work out Q3 minus Q2 and Q2 minus Q1, we can see which end of the distribution the data is more closely packed at. So 11.5 minus 6, or 6 minus 3. If you work this out, that would work out to be 5.5, and that's bigger than 3. If you look later in the booklet, this is one of our rules for skewness, and we'll talk about this in more detail later. So again, that shows us there is a positive skew, and the data is more closely packed together at the beginning of the distribution. And you would expect that, because if we're talking student absences, we'd expect most people to be absent a very small number of times, and only 1 or 2 people to be absent a large number of times. So we would expect the data to be packed at the beginning, very tightly packed, and then become skewed towards the end. So the answer to part C is that there is a positive skew and the data is concentrated at the beginning of the distribution.